Okay, guys, right. So we'll do question 34 to 38. Let's look at 34. So what we have here is it says that which of the following statements are true about ABC. Now, let's look at the first one. So a cost pool. So a cost pool really is if you like, a way of putting together similar, well, an activity, that's fine, but you can have similar activities, if you like, that consume resources. But we can identify similar overhead costs or similar cost drivers, if you like, that drive that pool of costs. So think of it like, yeah, like just really a pool of similar costs with a related similar driver, because ultimately we can't really have well, I mean, you can, but it would cost a lot to have a single cost driver for a single cost. Sometimes you will have one cost driver causing a range of similar costs, and that's what a cost pool is. So I really put here cost pool is an activity stroke activities which consume resource and for which overhead costs are identified and allocated. So it could be more than just one activity. So this is correct. An activity-based overhead costing absorption rate is calculated in the same way as the OAR. That is correct. And will result in the same OAR being calculated for each cost pool. Now that's the false part, because you see each cost pool will have a different cost driver, and therefore you will have a different OAR for each cost pool, if you like. So in effect, this is wrong, right? So really it's just one that's correct. So 34 is A. So we'll just make let's just, well, we can just do that. Well, I suppose I could just do, well, yeah, it doesn't matter, I'll do it here. So question 34 is A. So we have that done. Now let's look at the next one. So 35, thankfully 35 runs through, it's the same information, we just have to work out different costs. So let's do this one. So let's see what's actually happening here. So what we have here is that we have this thing called, this company called the ABC company manufactures two products, alpha and beta, and both are produced in very labor intensive, use similar processes, differ by volume. Beta is a high volume, we can see that high volume product, A is a low volume product. Details of, here we are, a series of, and there you've read this question, of course you've done it. So they want us to use a traditional method of overhead absorption costing, which means we just focus on this. All of this is irrelevant, right? Because we're using purely overhead traditional absorption costing. We take everything and we need some kind of base. So either machine hours or labor hours, and they tell us to go with labor hours. So the question here, of course, first of all is, well, what are the total labor hours involved? So for alpha, you are 5 hours per unit and you're making 1,200. So for alpha, you are making 5 times 1,200, which is 6,000 labor hours. And for beta, you are making 5 times 12,000 hours, which is 60,000. So in effect, you have a total of 66,000 hours driving this overhead cost of 420,000. So in effect, we can find, if you like, what the overhead absorption rate is, if you like, if you want to call it that, 420,000 divided by 66,000. So 420 divided by 66,000 gives you £6.36. So an hour of overhead, if you like, the overhead, you can almost call it like the direct overhead. If you like, an hour of overhead hour, and direct overhead hour is what costs £6.36. So when I'm costing a unit, just like I would with direct materials, direct labor, I now have the cost of an overhead labor hour. So the question says, I want to make each unit of alpha. So each unit of alpha needs 5 labor hours. So therefore, in effect, you will have £6.36 times 5 times 5, and therefore you have £31.81. That's what I get. Okay, great. So that's the answer there. 31. I think they just gave you a box to write that in there. 31.81. Okay, great stuff. Let's look at this next question, 36. So 36 says, a company uses ABC to calculate the unit cost of its product. So they're using ABC, and they're period 3. And so you have production setup costs. Production setup costs of 84,000 that we want to deal with. So these are production setup costs of 84,000. Okay, no problem. And the total production of A and B, each of each product is 40,000 units. So you have 40,000 units for A, 40,000 units for B, but they're done in runs of, so A has runs of 2,000 units, if you like, of A. So in effect, we will have 20 runs, right? Because if you're having 2,000 runs, if you're having 2,000 units being made in each run, you're making 40,000. That means you need 20 runs to get the total there. And you have 5,000 units being made per batch or per run. So in effect, you would need 8 runs. So basically, all these runs, in effect, these two cause this overhead cost of 84,000. So in effect, we now have, if you wanted to know what the cost is per run, it's $84,000 divided by 28 runs. So when I do that, 84,000 divided by 28, that gives me £3,000 a run. Per run. Right, brilliant. So, where are we? The question is asking, what is the setup cost per unit of B? Well, for every run, it's going to cost you 3,000, and you are making 5,000 units of B. Therefore, 1 unit of B, therefore, right, will be 3,000 divided by 5,000 units, which would be 60p, right? That would be 60p. Because every run, every batch, if you like, contains 5,000 units, and that's the cost, and therefore, for a unit, just divide both sides by 5,000 to sort of see what's going on. So the answer here would be 60p. Okay, right, good. Let's look at the next one. So the next one is the same information from 35. 37 is 35 in effect, but it's the same information, but a different question, right? So if you look actually at 35 here, we worked all of this out and we said that, okay, well, the cost, the OAR was £6.36. That's the cost of a labor hour. I mean, £6.36. I'm just going to go there, right? We know that is £6.36. And the question is asking, what is the overhead of each unit of, oh, sorry, did this ask for beta? For each unit of alpha. Oh, sorry, yes, this is asking for beta this time. Yes, this is asking for beta. If we go to, let's go to the original question so you can see it. It's asking exactly the same thing, but this time just for beta. This is 35 alpha, 36. This time it's asking for beta. That's all. That's all it's doing. So it's exactly the same question, but just asking for beta. Well, it's not so different because beta, every unit of beta requires 5 hours as well. So they are exactly the same answer in effect because they both use up 5 hours. It's £6.36 per, if you like, overhead hour. And therefore for 5 hours, if you like, you're having £31.81, if you like. And that's the interesting thing with that. So that's exactly the same thing. So exactly everything I've done, because you see it says traditional, so I'm not interested in this either. Right? I'm not interested. No, not interested in any of this. I just need to take this thing, split it exactly the same way I've done it. 420 divided by, the 6,000 plus the 60,000. And then get my OAR, which was this, and then multiply it by the number of hours. And I'm there. Okay, great. And actually, this is important because I've just been copying and pasting. It's important to see what the actual question is. It's the same data. I thought that would be faster, but actually not. The final question here, if you like, for this session, this short session, it says it wants to know, using ABC, what is the overhead cost per unit for each unit of alpha, but this time using A, B, C. So this time I'm using ABC. So not alpha, not traditional ABC. So now this matters. All of this matters. Right? All of this matters. So what you have to do is you have to sort of find out what's going on for each of them. How am I going to spread these costs based on each component of this overhead in effect? It says this is volume driven. So this is driven by the hours. We've kind of worked out the hours already. We know that these were the total number of hours. So we have a total of 6,000 hours plus 60,000 hours. So we have 66,000 hours. So I can find what the overhead absorption rate is per hour, right? Based on for volume, at least for this one, I know that's going to be, so for volume, it's going to be 100,000 over 66,000. When I do that, I get 100,000 divided by 66. I get 1.51 per sort of overhead hour. So for that one, that's that one. The purchasing related is related to the number of purchase orders. You have 160 orders in total. So what that means is that, oh, wait a minute, it's funny because I need to find out whether this question was looking for alpha or beta. I'll find out. We'll check in a second, but let's just do the overheads first. So that means that so for purchasing related, we're saying that we're spreading 145,000 divided by 160 purchase orders. That's what we're talking about here. So 145,000 divided by 160 is 906 pounds 25. And the setup related costs of 175,000 divided by 100, right? Because a total of 175,000 pounds is the total setup cost divided by the number of setups, which is 100, and here we have 1,750 per setup. So in effect, what I then now need to do is, if you like, kind of work out what's going on for each of them. Let me just check the question is, let me just know who I'm doing this for, whether I'm doing it for alpha, whether I'm doing this for beta. Give me a second, let me just see here. Question 38. Use ABC. What is the overhead cost per unit for each unit of product alpha? Okay, so that's product alpha I'm interested in. Right, so let's look at alpha then. So this is alpha here. Alpha has, if I look at for these, I'm interested, let me look at, I'm looking for, I need to do it as a whole. It sort of makes, it's clearer that way. I'm dealing with 1,200 units. So if I'm dealing with 1,200 units, what I want to do is first of all sort of deal with the number of hours. So I have for alpha, I have 5 times 1,200 hours times £1.51. So all of this is the total overhead for 1,200 units. Then I know that I have a total for alpha of 75 purchase orders. So I have 75 purchase orders, and each purchase order is £906.25. That's the total. That's all the overhead. And finally, number of setups. I have 40 setups times 1,750. That's what's going on over there. So when let's find all of this here. 5 times 1,200 times £1.51 gives us 9,060. 75 times 906.25 gives us, so you kind of have to do the whole thing as a whole because you want to know what's going on per unit, but you need to get all the overheads in there. 0.75, and then finally I need 40 times 1,750, and that's 70,000. So I'm going to add all these together. So 70,000 plus 9,060 plus 67968.75 is equal to that. So the total of all of this is 1,47028.75. That's the total cost, and to get the cost of a unit, I now need to divide this by the 1,200 units. Divide that by 1,200, and you get £122.52. That's what I get, 122.52. I suppose you could round it up to 53. And that looks like, let's see what answer that one looks like. That's C, right? That's C, and the answer there is C. So 38 is C. So just chucking in the answers on the board here. Question 38 is C. I believe question 35 was £6.36 times 5, which was 31.81. Question 36 was 60p. Question 37 was exactly the same as question 35, which is £31.81. Cool, great stuff. So that's question 34 to 38.